Hello and welcome to the Smart Farming final presentation video. My name is Luke Kernick.
I'm David Suret-Lesmes.
I'm Ryan Dolinsky.
I'm William Watson. The agricultural industry is at risk due to rising input costs, unpredictable weather conditions, and labor shortages. The implementation of smart farming solutions can improve the efficiency of farming activities, reduce costs, and satisfy growing demand for food while ensuring food safety for all. Our primary target customers would be commercial farms, agricultural corporations, and any scale food producers looking to optimize their labor efficiency and reduce annual operational costs. Some issues faced by our potential customers that we could address is an increase in food demand, unpredictable weather, pest, food disease, high cost, and staffing shortages. We are proposing the implementation of smart farming, which involves introducing technology to improve the farming process. We will do this through the engineering of 4 unique robots. Each one is designed to accomplish a particular farming task that addresses issues faced by potential customers. They offer an affordable, user-friendly approach with a versatile system that allows all 4 robots to create an all-in-one solution. Our proposed robots are the planting a seed robot, harvesting robot, soil sampler robot, and the chemical sprayer robot.
My robot is the planting a seed robot, and it uses 3 motors, 2 to drive and 1 to turn 2 rotations and to send seeds down the funnel to plant. It also uses a camera to see the seeds being planted and a distance sensor to drive forward 2 feet and then stop in a loop.
This is the harvesting robot. Its main objective is to pick and transport ripe crops. It uses DC motors to move in any direction and a combination of servo motors to operate the robotic arm and claw. When the ultrasonic distance sensor detects a crop within 1 foot, it safely picks it and places it into the storage tub.
This is a soil sampler. It is a machine that travels through the fields collecting soil samples for further analysis to help farmers determine if the soil needs irrigation or more fertilizers. It uses 3 ultrasonic sensors to navigate the field and detect and avoid obstacles. It uses also a moisture level sensor to read the moisture composition of different areas, and it uses a servo motor attached to a drill to collect the samples.
The chemical sprayer robot has 4 total DC motors. The first 2 operate the front wheels, the other 2 operate the pump that sprays out the fertilizer or chemical. It also has 2 servo motors that direct the pumps. It has a distance sensor that tells how much liquid is within the tank, and it's operated by a remote control. Starting with the plant a seed robot, it'll leave the barn. Using GPS coordinates, it'll go to his location and then begin to deposit seeds. Once it runs out of seeds or is done with coordinates, it'll return back to the barn. The harvesting robot will leave the barn. It will then look for ripened fruit. If it finds ripened fruit or crops, it'll pick it until the basket is full. From there, it'll return back to the barn. And then for the soil sampler, this also uses GPS coordinates. It is going to leave the barn, go to its coordinates, get the sample. Once it has its samples, it'll return back to the barn. And then finally with the chemical sprayer, it'll leave the barn using GPS location also. From there, it'll spray crops with either a fertilizer or chemical, whatever is needed. Once it either runs out or it runs out of coordinates or liquid, it'll return back to the barn.
For benchmarking and value added during research, we found that planting a seeds competition is the NIO Technologies Oz Ebra seeder. And while they are similar in design and drive, the planting a seed is more efficient in speed. Planting a seed also offers a camera so that the operator can see if the seeds are being planted properly. Also, we found that the chemical sprayers competition is the Farm Droid spray. Both machines do the same thing, but they are not very similar in design. The Farm Droid offers a micro spraying with fixed sprayers, while the chemical sprayer can spray many different size plants in all stages of growth, and it has 2 movable sprayers. In conclusion, this project allowed us to practice valuable skills learned in the course, including the application of engineering design decision-making process and project management. It taught us how to apply 3D design tools such as Fusion 360 or Tinkercad effectively and simulate automation conditions using Arduino boards, which are essential skills for our engineering careers. It also established smart farming as a potential solution to a real-world problem faced in the farming industry. The robots created enhanced agricultural efficiency, reduced costs, and improved sustainability as outlined in the design requirements. The designs could be scalable, adaptable, complementing other existing markets and solutions. With further modeling in testing the proposed designs could revolutionize modern farming, making it more efficient.